Number 4. Rewrite each expression as the product of a monomial and a binomial. How can you be sure that your product is a correctly rewritten form of the original expression? In this scenario, I am asking you to do what you did in scenario number 3, but in reverse. In scenario number 3, part A, for example, you distributed the x to this expression in parentheses, and you got the result shown here. Try to think about how you would do that in reverse. If you started with x squared plus 2x and you had to think about a binomial and a monomial that you could multiply together to get that, how would you do that? Well, let's do part A now. 5x squared minus 20x. First, look at both of these terms and try to figure out if there is some common factor. Look at 5 and 20. What is a number that divides evenly into both of those? That would be 5. Suppose you just left it as 5. And then in parentheses, you put a binomial that you could multiply by 5 to get this resulting binomial. Let's look at 5x squared first. 5 times what equals 5x squared? That would be x squared. And then the next part of this binomial, minus 20x. 5 multiplied by what equals negative 20x? That would be minus 4x. So here you have one possible product of a monomial and a binomial. But there's another way you could write this. There's a 5 that is a common factor of both of these terms, but both of these terms also contain an x. This is x times x, this is x. So 1x is common to both. So we can say that x is a common factor. That means 5x is a common factor of both of these expressions. Now I can write parentheses and put an expression inside the parentheses that when I multiply it by 5x, it equals 5x squared minus 20. Let's do one term at a time. 5x multiplied by what would equal 5x squared? 5x times x is 5x squared. So I can put an x right here. 5x times what equals negative 20x? 20x is 4 times larger than 5x. And this is negative, so I could put a minus 4. Because 5x times negative 4 is negative 20x. So here is another possible monomial and binomial product. A monomial times a binomial. Now this question here said, how can you be sure that your product is a correctly rewritten form of the original expression? You can do that by multiplying the monomial and the binomial together to confirm that you get the original expression. Now let's do part B. 6y squared plus 15y. Let's look at 6 and 15 first. What is the common factor of 6 and 15? That would be 3. 3 divides evenly into both, so we can write down 3. And then in parentheses, put the expression that would multiply by 3 to equal 6y squared plus 15y. 3 times what equals 6y squared? 3 times 2 is 6. 3 times 2y squared would be 6y squared. And then we'll look at the 15y. 3 times what equals 15y? 3 times 5 equals 15, and it's plus 15, so this would be a plus 5. And then we need that to be 5y to make it 15y. So there's one possible product of a monomial and a binomial. But we can find another product because both of these terms have a common factor of y. So we can pull out a 3 as a common factor, but we can also find y as a common factor. So the greatest factor they have in common is 3y. And then in parentheses, we will write what expression can be multiplied by 3y to equal 6y squared plus 15y. 3y times what equals 6y squared? 3 times 2 equals 6, y times y equals y squared. Combine those to make 2y. 3y times this equals 15y. That would be 3y times 5, and it'd be positive, so we'll put plus 5. So now again we see two possible products. This product involves the greatest common factor and the remaining binomial. And in part A, the red expression was the greatest common factor and the remaining binomial. Number 5. What are the values of A, B, and C in the rectangle shown? 2 of the values are side lengths, and the other value is the area of the smaller rectangle. These two rectangles are both smaller rectangles. This is the larger rectangle, the outer rectangle. So one of the rectangles has an area of 50x squared. B represents this missing area. We know this length is 3, and we know this length is 10x. Let's find the value of A first. A is this side length, so A times 10x equals this area, 50x squared. Let's write that down. A times 10x equals 50x squared. We can solve for A by dividing both sides by 10x. On the left side, we get A, and on the right side, 50 divided by 10 is 5. X squared divided by x is x. So A equals 5x. Now let's find B. B is inside this rectangle, so it's the area of this rectangle. Area is one length times the other dimension, base times height, length times width. So 3 times this equals B. And this is the same length as this, which is also this, 10x. So this side is 10x. 3 times 10x equals B. 3 times 10x is 30x. So B is equal to 30x. Now let's find C. C is this entire length, and if you look up here, there's 5x and 3. If you add these together, you get the length of C. So C equals 5x plus 3. 6. Draw a rectangle that has the following area. Label the length of the base and height. Part A, 11x plus 33. If I drew a rectangle and its area is 11x plus 33, then I want to think about what I would multiply together to make the expression 11x plus 33. If I look at these two terms and think about a common factor, 11 is a common factor of both 11 and 33. So let me write this expression as 11 multiplied by some expression. 11 times what would equal x? That would be 11 times x. And then 11 times this equals 33. That must be 3 plus 3. 11 times x plus 3 equals this, so I can let these be the side lengths of this rectangle shown. It doesn't matter which side you put them on. I'll put 11 here and x plus 3 here. That rectangle has an area of 11x plus 33. Part B, y squared plus y. Let's find a common factor of these expressions. That would be y. If I write it as y times some other expression, I can look at this result and then think about what would I put here such that y times that equals y squared. And that would be a y. Y times y is y squared. The next term times y equals y. Y times what equals y? That would be 1. So I put a plus 1. Y times y plus 1 is y squared plus y. If I make a rectangle then, one of the side lengths is y, and one of the side lengths is y plus 1. It doesn't matter where you put them. I'll put the y here and y plus 1. I'm not trying to draw a rectangle that is to scale. I'm just drawing one so that I can label its side lengths. 7. Rewrite each of the areas in the previous scenario as the product of a monomial and a binomial. We've already done this, so I'm just going to write C above and draw an arrow. A brief lesson on vocabulary. When you rewrite an expression as the product of two other expressions, as in the previous scenario, the two expressions are called factors. In this context, the word factor is a noun. Additionally, the process of rewriting an expression as the product of its factors is often referred to as factoring. In another context, then, the word factor is a verb. 8. Write each polynomial as the product of two factors. A, 7x plus 7. You can see that both terms have a common factor of 7, so I will write that first. And then in parentheses, I will write the expression that can be multiplied by 7 to equal 7x plus 7. 7 times what equals 7x? That would be 7 times x. 7 times what equals 7? That would just be 1. So plus 1. These are two factors multiplied together, so that is a product of two factors. Part B, 10x squared minus 35x plus 5. Each of these three terms is divisible by 5. So 5 is the common factor, the greatest common factor of all three terms. Now I can take one term at a time. I'll start with 10x squared. 5 times what equals 10x squared? 5 times 2 is 10, so 5 times 2x squared would be 10x squared. 5 times what equals minus 35x? 5 times minus 7 is minus 35, so I'll put minus 7x, because 5 times minus 7x equals minus 35x. 5 times what equals 5? 5 times 1, and that's positive, so plus 1. the trinomial here times 5 equals this trinomial. So this trinomial has now been written as the product of two separate factors, a monomial and a trinomial. Number 9, factor each polynomial. Part A, 3x squared minus 6x minus 5. Now you may look at this for a while and think 3, 6, and 5 have no factors in common. These two terms have an x, but this one doesn't. And if you keep looking at it, you actually won't find a common factor. And that's okay. I'm putting this here because I want you to realize that sometimes there is not a common factor. We can say that this expression is not factorable. You can also use the word prime to describe that expression. Something that is prime only has factors of 1 and itself. Part B, 8x cubed plus 16x squared plus 12x. There are many different factors of these three terms. They are all even, so you could factor out a 2. They are all multiples of 4, so you could factor out a 4. They each contain an x, so you could factor out an x. Between 2 and 4, 4 is a greater common factor, so I'll use 4. If you factor out a 4, you get the following expression inside parentheses. You can also factor out a 4x though, so I'll show what you get if you factor out 4x. Identifying a common factor can lead to different opinions. Consider the polynomial 8x cubed plus 20x squared plus 12x. The three terms of this trinomial share 2 as a common factor, as well as 4 and 4x, and even 2x if you want to add that in there. In situations like this, it is typical to identify 4x as the greatest common factor, GCF. 10. The terms in the expression below have many factors in common. Identify all of the common factors of the terms in each expression. Part A, 15x cubed plus 30x squared plus 45x. The smallest factor you might identify is 3, or x. You could also identify a factor of 5, or even 15. Or 3x if you combine those, or 5x, or 15x. The greatest common factor would be the one that contains the most factors overall. That would be 15x. Part B, 90x to the third power minus 30x squared plus 20x to the fourth. The smallest factor you might identify is 2, or maybe you'll see that 5 is a factor, or 10. Well, you can also see that they each contain an x, and even an x squared. So you could combine some of these to create other possible factors. 2x, 5x, 10x, or 2x squared, 5x squared, even 10x squared. And the one that contains the most overall factors in it is called the GCF, or the greatest common factor, and that would be 10x squared. That's the GCF, which stands for greatest or largest common factor, the largest factor that these expressions have in common. Number 11, identify the greatest common factor of each expression in the previous scenario. I explained that in the previous scenario, so for now I will just write C above. Number 12, factor each polynomial below by writing it as the product of a monomial and a remaining polynomial. The monomial should be the greatest common factor of the original polynomial. Part A, 2x squared plus 2x. 2 is a common factor of both of these terms, but x is also a common factor of both of these terms, so 2x is the greatest common factor. 2x times what equals 2x squared? That would be x. 2x times x is x squared. And then 2x times what equals 2x? That would be 1, plus 1. And you could check this by doing 2x times x and 2x times 1 to confirm that you get 2x squared plus 2x. Part B, 12x cubed plus 30x squared minus 24x. One common factor is 2. Each of these is even. They are also multiples of 3, and as a result they are then multiples of 6. So 6 is one possible common factor. But if I look at the variables, each of these has an x in them. Only one x. This has one x, these have 2 and 3 multiplied together. So we'll take 1x as a common factor. So I can write 6x as my greatest common factor outside the parentheses. Now I have to think about what 6x can be multiplied by to equal 12x to the third power. 6 times 2 is 12. X times x squared is x cubed. So 2x squared. 6x times what equals 30x squared? 6 times 5 is 30. X times x is x squared. So 5x, and that would be plus. Finally, 6x times what equals negative 24x? 6 times negative 4 is negative 24, and these already both have an x, so I don't need another x. So it's just negative 4, or minus 4. And you can confirm that this times this equals this trinomial by distributing the 6x again. Part C, 16x to the fourth minus 80x cubed minus 40x squared. Let's look at the coefficients first, and we can see that one possible factor is 2. All of these coefficients are even. Another possible factor is 4. They're all multiples of 4. And 8 as well. 8 is the largest possible factor that each of these coefficients have in common. And now I can look at the variable parts. X to the fourth, x to the third, x to the second. This has 2 x's multiplied together, 3, and then 4. So 2 x's multiplied together is contained in each of these terms. So 2 x's multiplied together is part of my common factor. And I can write that as x squared. 8x squared is the greatest common factor of this trinomial. One term at a time. 8x squared times what is 16x to the fourth? 8 times 2, and then x squared times x squared. So 2x squared. 8x squared times what equals minus 80x to the third? 8 times negative 10 would be negative 80. X squared times x is x cubed. So minus 10x. 8x squared times what equals minus 40x squared? That would be negative 5. So I'll put a minus 5 here. And there's my factored form of this original trinomial. 13. Factor the trinomial 18x to the fourth plus 60x to the third minus 30x to the second. Let's look at these coefficients first. 18, 60, and 30 are all divisible by 2. They're also divisible by 3. If they can be divided by 2 and 3, then they can be divided by 6, and that's the common factor. Each of these terms is divisible by 6. Now I'll look at the variable parts. X to the fourth, x to the third, and x squared. X squared is a common factor of x to the second, x to the third, and x to the fourth. Now I'll write parentheses and look at what goes inside the parentheses. 6x squared times what equals 18x to the fourth? 6 times 3, x squared times x squared. So 3x squared. 6x squared times what equals 60x to the third? 6 times 10, x squared times x. So 10x. And then finally, 6x squared times this expression equals negative 30x squared. 6 times negative 5 equals negative 30. X squared times 1 equals x squared. So in this place, I would put a minus 5. There's my factored form. I can always check by multiplying this 6x squared back through to each of the 3 terms and confirming that they give me this original trinomial. 14. A rectangle is divided into 4 smaller rectangles as shown. 1, 2, 3, 4. Calculate the area of each of the smaller rectangles. Write the area of each smaller rectangle inside the space of that rectangle. Let's look at this one first. Its height is x and its base is x. X times x is x squared. How about this rectangle? It's 10 along this edge, and this edge has the same length as this one, which is x. So this is x, and 10 times x is 10x. Now let's look at this rectangle. 2 times this is its area, and this length is the same as this one, so that's x. 2 times x is that area, 2x. And then finally, this rectangle, this dimension is the same as this one, so it's 2. And then this has the same length as this one, 10. 2 times 10. 2 times 10 is 20. Now I can move on to 15. 15. Consider the rectangle below. The areas of 3 of the sections are shown in those sections. Part A. Determine the area of the missing section below. This section has an area of x squared. This section is 6x, this one is 24, and this is the one that we don't know. So let's start filling in the side lengths since we know the areas. If this has an area of x squared, then I could have x squared and 1, or I could have x and x. If this has an area of 6x, then I could have 6 and x, or 3 and 2x. When I look back at this one, if I have x here and x here, that gives me an area of x squared. So suppose I put x there, and then x here. Well, then this would be x, and this would be x. If this is x here, then I can put an x there, and an x here. And going back to this area, if this is x, then this would be 6 to make the area 6x. So I can put a 6 right there, which means that's 6, and that's 6. And now I can look at this rectangle. Its area is 24. 6 times what equals 24? That would be 4. 6 times 4 is 24. So I can put a 4 here, which means this is 4, and this is 4. And now I can find the area of this rectangle. Its base is x, and its height is 4. 4 times x is 4x. So the missing section is 4x. Part B. Determine the area of the entire rectangle. The entire rectangle is made up of these 4 smaller rectangles. So we can add each of these 4 expressions to get the area of the larger rectangle. X squared plus 6x plus 4x plus 24. And we have learned that we can combine like terms. Plus 6 plus 4 is plus 10, so plus 10x. And I can bring down the plus 24 and the x squared. The area of that rectangle is x squared plus 10x plus 24. 16. Consider the rectangle shown below. Part A. Determine the expression for the area of the entire rectangle. Well, to find this entire rectangle, I need this missing area. So let's start thinking about how to label these sides to get these given areas that I have seen. 3x could be 3 and x, or 3 and x. It could also be 3x and 1. But if this is 3x, then 3x times what equals 27? There's no x in that 27, so these need to be integers that multiply to equal 27. We could make this more complex and put fractional values and other types of expressions, but for now let's assume we're just looking for x, x squared, integers, things like that. So this times this equals 27. That could be 27 and 1, or 3 and 9. If this is 3 and this is 9, then this has an area of 3x. This could be 3 and x. So let's go ahead and write that. If this is x and this is 3, then I know there's a 3 here and a 3 here and an x here and an x here. Since this area is x squared and this is x times what equals x squared, this must be x also. X times x is x squared. So I can put an x there, which means an x goes there and an x goes there. Going back to this 27, 3 times what equals 27? That would be 9. So I can put a 9 here, which means this is 9, which means this is 9, and now I know the area of this missing space. It's 9 times x, or 9x. So the area of the entire rectangle is this area plus this one plus this one plus this one. X squared plus 3x plus 9x plus 27. I can combine these like terms and write x squared plus 12x plus 27. That's the area of the entire rectangle. Part B. Write the area as the product of its base and height, or base times height. The base is x and 9, and we would add them to get the entire length. So the base is x plus 9. And the height is 3 and x, 3 plus x. If I use the standard form, I can put x first and then plus 3. So the product of the base and height would be x plus 9 times x plus 3. And we could prove that makes sense by using what we've learned in the previous book, book 4, multiplying binomials, x times x, x times 3, 9 times x, 9 times 3. Those separate products combine to form x squared plus 12x plus 27.